Tired of your games looking a bit bland? Want to inject some cartoonish charm? Then this video will show you how to achieve stunning toon shading effect in Unity using shader graph. First, let's discuss what is a toon shading. Toon shading is a lighting technique that can give you anime-like or cartoon-like visuals, hence the name. The more technical term is cel-shading. Alright, I'm using Unity 6 and my project is set up in URP. Then I have this scene and I have this nice totodile model. Now first let's create a shader. URP unlit shader. Why unlit? Because I'm going to do the light calculation in the shader itself, and if I choose lit shader, my light calculation will be added or appended on top of the PBR lighting, which obviously I don't want, hence unlit. Then I'm going to name it Toon Shader. Then we need material, so right click, create material. I'm going to call it totodile body. Then apply it to my totodile. Now my totodile mesh has multiple material slots, one for the body, another for this eyes part, and this third one for the actual iris. Well, I don't care about the iris, but I need to create another material for this part. So I'm going to duplicate my material and let's call it totodile eyes. And apply it into the second slot. Then in the shader, let's calculate diffuse lighting. And to calculate the light, we need two things, normals and light direction. So I can get the normal using normal vector node. And I want the normal in world space, so keep the drop down to world. Then for the light direction, I can use main light direction. Main light direction will give me the direction vector of the directional light. However, light vector should point from the fragment to light source. So basically I need opposite of this vector. So I will use negate node. And negate node will simply go input multiply -1. Now one thing to notice, both these vectors are unit vectors or directional only vectors. Now let's calculate dot product between these two. And we have this nice preview. Imagine that this is a 3D sphere and our light is shining from this top right corner. So at this point we will have value of 1. Like let's imagine that their normal and light direction will be parallel, so light will be most intense at that point, and as we move away the normal vector will deviate from the light direction and we will get this nice light fall off. Not exactly fall off, this nice linear fade that goes from 1 to -1. I don't want negative values, so I'll just use saturate node, which will clamp the value between 0 to 1. And this will be our diffuse light. Alright, now I also need color for my light. And interestingly, we do have main light direction to get light direction, but for some reason there doesn't exist any node to access the light color. So that leaves us with two options. Either create a C# script, access the directional light's color and pass into our shader. But in my opinion, that would be a little bit difficult to handle. So I'm going to create a custom node. So let's go custom function node. Select the custom function node and open up the graph inspector. And we don't need any inputs. And as an output, we will return a color. And here I don't need alpha, so I'm going to set the type to vector3. Then in this type drop down, instead of using file, I'm going to select string, and it will allow me to write the code in this body text area. But first let's give a name. Let's call it main light color. And for the code, let me open up Notepad so we can see the code better. So first I'll go light, and let's also call it light equals get main light. and then I'll simply go color equals light dot color. Also make sure that this color is spelled exactly as your output. Now here I have one slight problem. This light type is not a built-in HLSL type, and this get main light function is not a built-in function. Both of them are defined in lighting.hlsl, I believe, which comes with the URP package, and they're defined under universal lighting included keyword. So I have to wrap the entire code with hash if preprocessor, and then I will go defined and then go universal lighting included, and then here I have to go hash and if, and this is like a conditional compilation, so compiler might think that this code might not even execute or might not even be reachable. So if I directly copy paste this, I might get an error that I haven't defined or initialized this color output. So before I do all of this, I will simply go color equals black, so 0, and you can define the vector3 like this. So it basically means 0 in all 3 channels. Or actually, let me define it as white color so we can actually see the preview. Then copy this and paste it in this body, and there we have a nice custom function. Then I will simply multiply these two together, and let's visualize that. So now I have calculated basic diffuse light, and it will react based on this directional light's angle. So that's pretty cool. Now here you can see that I have a lot of this black parts where light is not reaching, and I don't like that. So let's also calculate ambient lighting on this black parts. So here I have diffuse lighting that linearly goes from 1 to 0, and all of this black part is also 0. So basically I need inverse of that, so I'm going to use 1 minus node. And 1 minus, as the name suggests, will go 1 minus this input. In this case, it will invert our values here. Then to control the ambient light intensity, I'm going to create a new property. Let's go ambient intensity, and let's default it to 0.2 and set the mode to slider, which goes from 0 to 1. Drag it in, multiply it with our 1 minus node, and to access the ambient color we can use ambient node. And to keep things simple, let me use this color slash skybox input and multiply it with this one. So here we have ambient lighting, and I'm going to add it on top of my diffuse. And let's visualize that. And now our mesh looks a lot better. By the way, one thing I forgot to mention is this light calculation will be per fragment, which will be slightly expensive than vertex lighting, but it will look much nicer. But this doesn't look like Toon shading. We have just simply calculated blend fong. Well, it's not even blend fong because I haven't calculated specular lighting. So let's make it look like Toon shading. And for that, I'm going to use this dot products output. So let me make some room here. So here in the dot product node, we have value that linearly goes from 1 to -1. And if I somehow make it non-linear, we can get that Toon shading look. And the easiest way to do that is, in my opinion, gradient node. This will allow me to have a nice control over the blend without including complicated maths. Okay, let me define a nice gradient. So I'll set the first pin to black and set it at like 45% location. Then I will add a new pin and set it to, let's say, 0.4. Whoops. And set it to like 58%. Then one more pin at like 85%. Again with the value of 0.4. And last pin will be at around 88%, and it will be full white. So this black part will be our shadows, this is our midtone, and this is our highlights. By the way, you can of course experiment with this. Then we need to sample the gradient using sample gradient node. And this time input has a range between 0 to 1. If I pass in 0, I will get the color from the very left of the gradient. If I pass in 1, I will get the color from the very right. And obviously if I exceed this range, I will get the color from either of these edges depending on the input. Now what I'm going to do is I'm going to remap this dot product value to go from 0 to 1 instead of -1 to 1. So let's take its output and feed it into remap node. Then we will tell that original range is -1 to 1 and we want 0 to 1. Then I'll take its output and use it as the time input. Then I will simply take its output and multiply it with our light color, and we don't need the saturate node anymore. Then for the ambient lighting, you can of course create another gradient, but I'm going to keep things simple and take this output and feed it into 1- node. And now we have this nice shaded lighting. Pretty cool. Now obviously our mesh will going to have its own base color. So let's define that as a property. I'm going to create color property. Let me call it tint. And let's set the default value to be white. Let's put it on top. Drag it in. And let's multiply it with our calculated lighting. So just multiply add with our tint and use multiply node's output as base color. So now I can adjust the tint color of my surface, and it also reacts to the color of directional light. Pretty cool. Now in Toon shading, there is also a concept called rim lighting, which is simply a light that's shining from behind the object, and it will help us distinguish the object from the background by adding like sort of silhouette at the edges. Well, not exactly silhouette, but you got what I'm trying to say, right? Alright, so to add the rim lighting, I'm going to use Fresnel node. And then we will have this nice effect, and I can control this using this power input. I want to control it from the inspector, so I'm going to create another property. Let's call it rim light power. Let's default it to 10. Drag it in and feed it into this power. Then I also want to control the color and intensity of the rim light from the inspector, and for that I'm going to create new color property. Let's call it rim light color and set the mode to HDR so I can select color and intensity using a single property. And let's default it to 1 with the intensity of 1 as well. Drag it in and multiply it with the Fresnel node. Now I simply cannot add these two together because let's say we have a base color of yellow, so 110, and rim lighting of all blue, so 001. So if I add that together, I will simply end up with white color, which we obviously don't want. So So before I add this multiply, I'm going to use another 1 minus node, then multiply it with my base color. So this will simply remove the color from the edges and turn them all black, and then I can add these two together like this, and let's visualize that. So now I can control the rim lighting separately, and it will be like the exact color that we specify. Pretty cool. Now my Totodile had texture, so let's adjust our shader to incorporate that. So I'm going to create a new property, texture 2D this time, and let's call it base map. Drag it in. Also make sure you set the mode to white so that if any material doesn't use any texture, it will still work. Then let's sample the texture using sample texture 2D node. Then before we multiply the tint with our lighting, we will multiply our tint with our texture. So go multiply with our tint, and then use this multiply here instead. Then let me apply the texture to my materials. So for the eyes, I have this texture, and for the body I have this texture. Then let's adjust our materials. So let's add the rim lighting to like blue. Copy, paste it in the eyes as well. By the way, you can get the project file from my Patreon. Well, Totodile will not be included due to licensing issue. I simply cannot redistribute it. And there we have a nice toon shading. Pretty cool. Now before you click off, I have to clarify that this is not a game ready effect. It is just a starting point. Currently, I haven't included specular light calculation. It doesn't even account for additional lights in our scene, and it probably won't work with light maps, baked lighting. And I'm going to leave all of that up to you. Now, you might argue that why haven't I included all of that? Fair point, but to be honest, toon shading is a bit complex topic. If it was easy, you won't have all that Toon Shader paid asset in the asset store. A perfect Toon Shader would cost me a lot of time to create, and I simply cannot justify spending too much time and effort on a single video. I hope you understand my situation, and that's it from me, and I'll see you in the next one.